In this third part of the Simulink tutorial, I'm going to show a few functions and features that are useful to know. So first of all, when you run a simulation like this, it may be helpful to go in what I call the model configuration parameters. These parameters include a bunch of parameters of the simulation that here we go. So here's the window, and we have a few different tabs here. The ones that I'm going to look at here, first of all, is the type of solver. This is a variable step solver, which is good for offline simulation. When we do experiments in the lab with DSpace, we typically use the other option, which is the fixed step. Sometimes I found helpful to reduce the relative tolerance. If you take a smaller number, like 1e minus 6, you will increase the precision of the simulation. Sometimes it's helpful to do that to see if the results are the same, to make sure that the simulation is reliable. In data import and export, notice this option here, which can be really frustrating. If you leave this option here, only the last 1,000 data points are saved. So if you had a long simulation, you could find yourself in a situation where only the last part of the simulation is visible. So if you want to avoid that, you will have to uncheck this box here. Now if I go to diagnostics, you find here this pesky warning sign that we've had when we ran the simulations in the first two tutorials. This is the warning, which is somewhat useless, and you can change it to none. And you can look at some other details, but these are, in my experience, the most important ones that I have used. Another interesting heading here is if you go to File and Model Properties, there is a callback tab, and then there is an init function. This is a function that's run before the simulation is run. So you can put some initialization functions here, and in particular initialize some parameters. So if you said kp is 0.02 and ki is equal to 4, then these would be initialized in the Simulink workspace. So if I click OK here, if you like, then you can go into this block, and instead of putting a number, you can put ki, which exists now, and here you can put kp, and these variables would be coming out from the initialization. So if you run it and you look at the scope here, you see the simulation hasn't changed. So having this ability of setting parameters initially can be good if the same parameter appears in various places. What you can also do is, if you have parameters of the plant and then parameters of the controller that are a function of the plant, you can put the plant parameters in the initialization function as well as the computation of the controller parameters. So that can be really quite convenient. Now another feature that I'd like to draw your attention to is the following. So if I left click and create an area here, I can highlight this area, and this turns out to be the controller. So if I now right click on this, I can say create a subsystem, and everything disappeared here and was replaced by a subsystem. If I go inside the subsystem, you see that the controller is back here. It has been inserted in the subsystem, and these tabs here are the input ports and the output ports that correspond to the diagram. So if I click back on top here, I will come back to the diagram, and if I like, I could change this name here to PI controller. So this is really convenient to simplify diagrams that become very complicated by creating some kind of hierarchy, and then when you have a block, you can double click on it and see what's inside. And so you don't have diagrams that become unmanageable. Another advantage is that sometimes you can create libraries, so you can reuse whole blocks. So I could take this PI controller and then reuse it in various other places. Okay. So finally, I'd like to find my my library here again. I'd like to say, I would like to encourage you to go to all these functions here and see if you recognize any that you find useful. I'd like to point out just a couple of them here. And this non-discontinuity shows a lot of blocks that you find sometimes in control systems, especially the saturation. So that's a limit. So for example, in a motor control, you may have a limit on the voltage, and you can put that limit in the simulation using these blocks. In the signal routing here, you will find mux and demux function, so multiplexer, demultiplexer. What these do is transform a group of several scalar variables in a vector variables, and then that vector variable you can manipulate just like you would in MATLAB. So sometimes in some blocks, so if I had a gain here, if this signal here was a vector, then it would be all the elements would be multiplied by 1,000. And so again, you can go into all these lists here and see if you can find a function that you like. Sometimes it's also quite convenient to go back and type it as a MATLAB function if you can't find it, or sometimes it simply may be easier or faster to do so.